Right, and welcome back. Um, my name is Abel Gray Cantoma from GREYTEST Design Consult. This is my WhatsApp contact. You can reach me on this number or call me on any of these numbers. Okay. We are going to continue where we stopped. It was quite unfortunate. I was not able to add that load on my building at this particular story entirely. So I will have to just do it by picking just one beam. Let me just pick a particular beam and add this wall load on it and then copy to other beams. That is another way to do that. Anyway, so I will right click on it, edit load, and I will come to my wall load. Right, so I will just simply just click here in order to add that load to this particular member. Alright, so that load has been added. I will click on OK just to take this off. Alright, I can just simply right click on it again and then copy the load. Since on all your building, on all the structural members rather, wall load is usually just on beams. So even if I highlight the entire model or the entire structure rather at this particular story level and I paste, it is only going to paste on just the beams alone. Okay, so I will paste. So this is just one way to bypass that other challenge that we were having on trying to load on the entire structure. Okay, so all I will do at this point is to copy the loads. Okay, I can simply just highlight this right click, let me use a filter tool so as to filter this filter selection. All right, let me just select just the beams. Okay, it's quite difficult to do this at this level, but let's come back to story 6 so that I can manually just paste that. So I'm at story 6. Let me try my luck at this level and see if it will work perfectly. I don't know what the problem is with the other floors that with this particular story that it didn't work. All right, so let's go to load editor. All right, I will come to my wall load. Now let me try to highlight and see. Oh, perfect, it has worked. Okay, so I will just simply close this. So it's way easier to do it this way, most especially when you know you have your wall load on all the beams, right? Good, so you can see that has been achieved as well. We can do similarly for our story 7, right? Just come to edit, load editor, right? Come to wall load. All right, let's try it again here. Then just highlight the model. Right, let's wait for it. Right, let's go over this. All right, I'm just gonna do this manually by just simply picking on just one, and then come to edit load, or I can use this one. Whichever one I use is still okay. I'll come to wall load, and I will do for one and copy and paste on every other beam, so you will still achieve the same result. Okay, all right. So I will click here and I'll click on OK. Right, so at that level, I will select the load, I will copy, right click, copy load, click on OK and highlight, and right click and paste the load. Okay, all right, by now I'm sure you have gotten the concept of how to add your wall load your to your model. Okay, so for some other parts I'm just going to leave it as it is. The next thing I'm going to do is just to try to analyze this model and then run the design. we'll just come to my analysis, go to my building analysis, and I can just analyze this. Sorry, analysis. You can run a building model check. It's very important, so as to know if you could have some overlapping in some cases. You see, these are all the possible errors that you can get in your model: overlapping slab, overlapping column, overlapping slab with beam and walls. So these are all the possible errors you can get from your model. So if you are getting any of this error, then you will have to come back and check your model. Okay, and then I'm just going to run the analysis of this design. Okay, so I'm going to check everything. As you can see, we have a composite beam in our model, right? We have a steel member in our model, right? And we have a beam. We have, these are reinforced concrete, So I'm just going to check all of this. All right, and then I will run the analysis. So it may take a while depending on your system capacity. If your model is this large, that will determine how fast this analysis will take. Okay, so so we'll have to wait for it to finish loading. Right, so I'll click let me click no. Okay, so after the analysis, I will come to post analysis to check my designs. Okay, so you can carefully go through to see all of this. All right, okay, so I wouldn't go deep into checking all of my design reports and all of that, but as you can see for yourself, you can see how it works for each of these. You can simply double click on each of these member, and another good thing is you can group similar members. Okay, there are cases where you have similar beams, similar columns and all of that, so you can do a grouping. You can group them. Now if you come to automatic group, you can group all similar axes. Okay, so group, it will help you to group all those similar beams that you have. Okay, so because you know, if you are familiar with manual detailing, you agree with me that there are a lot of cases where you have similar beams in terms of their length, in terms of the reinforcement, in terms of the load that is coming on it, so they are similar. So in that case, you don't need to keep repeating similar beams on your detail. Okay, so that's basically what Prota Structure does for you. For every structural member, you can actually group. Okay, so I wouldn't go too deep into checking all of that. I believe if you have been following on a Prota Structure, you will agree with me that I have spoken extensively on all of these things before. Okay, um all right, let's come to, we have been able to do our analysis 100%, although some of the members have failed. but I will not go deep into trying to fix those structural members that are failed. I knew that there will be some members that will fail, most especially for this beam. I'm sure there is a high tendency that it may fail. These ones, they may most likely fail because of the span. So in that case, the best thing to do is to increase the depth of this beam. But although I'm not going into that, as you can see, I just use the default cross section of each of those structural members that was given to me by the software itself. Okay. There is another very important aspect that I did not actually really touch. If I'm to go into that, I will have to reanalyze this all over afresh. But what I will do is I can quickly let's say I delete this particular slab at so I'm going to delete this. You can see the analysis is no longer going to be valid anymore, so I will have to reanalyze afresh. Okay, but nevertheless, let's just delete this. So I will delete it across every other floor. Okay, so that I can introduce, let's say we have a shear wall here. All right, so let's say we have a shear wall here. So that will be on all the floors. I will have to come and I have to delete this particular slab across all levels. Okay, so what I will do is I will pause this video and go through each floor and delete it. Okay, so I have been able to delete the particular panel across all levels. So but let's go to our story one. At this story, I'm just going to create it inside here. If I said I should create it along this edge, I will have to delete each of these beams and delete the columns, and it's going to be a lot of work. So the easier and faster way to do this, this is really not a live project per se, so we are just trying to explore and see what we can achieve with our Prota Structure software. Okay, but then some of these challenges are important for us to go through some of this in order for us to have a better understanding when we are faced with similar challenges like this. All right, so I will just, let's say this grid is here, and let's say we have for this, let's say I copy this or use offset. I won't specify any distance, I will just drop it. Let me just move this a bit. Let's assume here is the center. Okay. So I'm going to draw a core wall here. Mind you, this wall is going to be a shear. You can see it's a shear wall, so it's reinforced concrete. So like I'm just going to draw this. Oh, sorry. Let me create another grid here. So this one, I'll set it around here. I will leave it here. So I'll draw a core wall. So let's say this wall is here. It goes this way. I have another one coming this way. Another one this way. Another one this way. So what I'm going to do is I can simply let me just select because there is no much space for me to highlight it, so I can simply just select and merge these vertical walls. So you can see I just merge these walls together. Now it has been merged, right? I can right click on it. It has become like one single element, right? If I right click on it, I can come to polyline wall editor, right? And I can insert my reinforcement on these walls. Okay. All right, so we are here. We can use the automatic curtailment. So if I click on automatic curtailment, you can see this is basically what is bringing out. I can add a head zone. I can specify the corner bar diameter, which is the bar diameter. Okay, so however I want this to be, I can specify all of that, and then I will click on OK. Now you will discover that your entire reinforcement detail, you can see, has been generated on my core walls. So I can simply click on OK. These core walls, now I can generate this member up to story, from story 2 up to story, I'll hold on shift up to story 7, and I'll click on OK. You know, I have already tampered with the analysis already, because the moment you do your analysis and you add any member, any structural member, or you edit any member, that analysis will become invalid. Okay, so you will have to reanalyze your structure again. Okay, so that is that. The process is complete. So it's complete. I can just close that if it's done. Right, so let's view this and see. You can see this core wall has been generated, right? Okay, that is that. I just wanted to demonstrate this. Let me show you one other feature. Although it's not really very new, but I know a lot of people don't really get to know how to do that. You can see I just use my polyline. I can use my polyline to achieve any kind of shape. I will right click here and click on continue with arc. So you can see this is the shape I have. Let me show you something very interesting. I can just right click on this and convert to column, and you can see that has been converted into a column. So all I need to do is to specify the cross section of this column, and I can look for a grid and insert this column. So you can see that column has been generated for me. You can see how very interesting Prota structure is, right? It makes your work way more, is becoming more flexible by the day. They are really working seriously on these softwares, and it's becoming way more flexible and way more easier to actually model with. All right, so we have been able to cover extensively on most of the basic common tools that you most likely use in your Prota structure, right? uh, so um, uh, right, so I've been able to do that. um, so the next thing I'm going to do, let's go to our, sorry, I may not reanalyze this because it's going to really take so much of our time to reanalyze this all over again. But I'm sure you have been able to see how to come about your analysis on Prota structure. So I will just quickly uh, insert some beams here. I'm just going to show you various kind of foundation that you can achieve with Prota structure. So this is going to be a strip footing. And I will select some columns and insert some pile tabs, so we can have some pile foundation on some of the columns. This is just me trying to explore, insert a pile cap. So I'm not really going to go deep into explaining the pile. I think the it's telling me the analysis is not up to date, I think. So we will have to reanalyze it. So we don't have a choice. Analysis result is not up to date, so I have to reanalyze this. We don't have a choice, so let's just reanalyze this. Okay, so let's run the analysis. Let's just run the analysis. Okay, all right, so we have been able to successfully reanalyze our model, right? So we can come back to our story 0 to quickly insert, let's say we insert our pile tabs on this particular columns, right? All right, it's loading. All right, I'm just going to accept whatever it gives to me. This is just to okay, so you can see what we have there. Similarly, you can also insert pad footing. You can insert pad and right click and insert pad. Okay, so I'm also just going to accept this as it is. You can do a raft for this. You can use a rectangle a rectangle to draw around where you are going to be having your raft. Okay, let me draw this around here. So let's say this area is where I'm going to be using for my rafts, right? I can insert the thickness of the slab and just so this is my rafts. I'm going to be generating here as rafts, and let's say this one is a strip footing. Although if you look at this model, I think this one and this one are not going to be relevant. So this is just where we have this. So let's say we have this as a strip. I hope it will allow me insert my strip footing. I just deleted the structural member. I can't. Okay, fine. But we have been able to get the concept so far on how to generate most of your the pile kind of foundation, the part kind of foundation. Your strip footing is the one we were just about to do. All you need to do is just to right click and click on insert strip footing, and it will be inserted. It will pop up a menu for you where you have to specify the width, the thickness of your footing. Okay, although there is more to it, I have spoken extensively on each of these types of foundation already in my other videos that you can find on my channel. Just visit the channel, just go down below the description of this video. You'll find a link to the YouTube channel. Visit the channel to keep yourself busy. Okay, if I come to slab strip, I can simply just strip this. I pray it will be able to run the strip because of the analysis is not up to date anymore. So I'm going to use a fixed band strip. So I will strip this way. I can hold on control in order for me to get a straight line. So I will click this point and click here, click this point and click here, and I will update. So you can see it has covered the entire area of this strip. I can switch this to y-axis, and I will do similarly. Hold on control to draw my strip. I will click here and click this point so that it will cover the entire area, and I will update. So we have been able to generate our strip at this point. All I need to do is to just come to my analysis and go to my FE foundation analysis. I can be able to I'll click on floor mesh and analysis, supported vertical member detected in upper level. Yeah, we have other members at the upper level. Remember, based on okay, you can see the Boolean analysis is not done, so I have to really run the entire analysis all over to be able to achieve that. But so far so good. As you can see, we have been able to extensively cover I think the major part of our structure using Prota Structure 2024. You can see how flexible and how interesting it is. You don't have bugs compared to other previous versions of the software. You can see everything so far so good has been going very smoothly. um let's try to go to our Prota still and see if we can be able to uh do something there. The analysis is, please analyze the model first. Oh my god, this has been my major challenge with this. um because of how large the model is, it usually takes a bit long time to really achieve the entire analysis. um but I will have to reanalyze it. By the time I analyze it, and then we can be able to view the steel members, um, be able to touch some of the major steel connections in our Prota steel, and then also go into our Prota detail, generate some of the structural members you are going to see for yourself. All right, so let's reanalyze it. As you can see, you have to keep reanalyzing the moment you make any change on your model. You have to reanalyze it. Okay, so you can see it's showing me a red indication here, like a star, showing that this analysis is no longer valid. So I will have to rerun the analysis. Another thing about this is that when you the software has what we call, when you go to your visual interrogation, there are a lot of features you'll be able to easily see that will help you to know some of the structural members that have failed, some of the structural members that have passed. Okay, you can see here is what we call the visual interrogation. So you can see this is our design statue. If I click on OK, you can see it brings out this table for me, showing me that the red indication means it has failed, the yellow means warning, and this means it has expired, and then the green is okay. This one means do not design, and then white is not designed. Now because my analysis is no longer valid, so that is why we are not seeing any red in any green indication. There is tendency when we analyze these, most of them may pass and probably some of them may fail. Like I told you, if you could remember from the previous episode, I made mention the fact that this structural member will most likely fail because of the span the load is carrying here. But I'm sure if I increase the depth of these beams, high chances are that it will pass. Okay, but that is from practical experience, sorry, and from years of experience so far, I can be able to tell. um okay, so let's reanalyze this. um just come to your analysis and click on building analysis, just like we did earlier on, and we'll just rerun the analysis all over again. So this is the third time we are rerunning this analysis. After this, we will not go into analysis anymore. We'll just go straight into generating our detailing, so that we can be able to see what the software will be able to generate for us. Okay.